Alright, this video is about volumes of known cross-sections, and so this goes along with discs and washers, which we did in 7.2. As a matter of fact, this is still in lesson 7.2. When we talk about cross-sections, there's some important things to know. First of all, the question will ask to find the volume of an area that has a cross-section that's perpendicular to the x-axis or the y-axis, but it will not say anything about revolution or revolving. So if you don't have the word revolution, then you don't need pi in your formula. So that's really important to remember, because when we did washers, we had pi r squared minus pi r squared, so we had pi on the outside of the integration. But now, when you have cross-sections, there will not be a pi on the outside of the integral unless something else in the formula calls for it. So first of all, we're going to graph this. X squared plus y squared equals 4 is just a circle. So I'm going to draw a little circle there. Now, what we have is this area here is the base. And coming off of that base are going to be cross-sections that are perpendicular to the x-axis. And then what they tell us that for is so that we know which direction to do our base. So if they're going to be perpendicular to the x-axis, then they're going to go up and down like this. So that tells me when I'm trying to find the base that goes into most of these formulas, the base is going to go from the top curve to the bottom curve, because that's going to be perpendicular to the x-axis. Okay, so this says find the cross-section that's perpendicular to the x-axis, and those cross-sections are going to be squares one time, they're going to be equilateral triangles one time, and they're going to be semicircles one time, and we're just going to use a different formula for each one. So since we're looking for volume, keep in mind that if you have an area already and you integrate it, integrating an area will give you a volume. So since we have this formula x squared plus y squared equals 4, we need to know specifically, if we were to solve this for y, what would be my equations. So this top half is the square root of 4 minus x squared when you get y by itself, and this bottom half is the square root of 4 minus x squared, except for it's going to be negative because it's the bottom half of the circle. So because this circle is not a function, we have two formulas that put it together. So if I'm going to find the base, which is going to go from this top section up here to this bottom section down here, I'm going to take the top curve minus the bottom curve to get the base. Okay, so we'll look at that in the next part. First of all, we're going to talk about squares. So we need the base, because the formula for cross-sections that are squares is just simply the base squared. So I just need to know the base. So I'm going to do the top curve minus the bottom curve, because it's perpendicular to the x-axis. If this was perpendicular to the y-axis, we would do right minus left. So my top equation was the square root of 4 minus x squared, and the bottom equation was the negative square root of 4 minus x squared. So the square root of 4 minus x squared plus the square root of 4 minus x squared is 2 square roots of 4 minus x squared. So that's my base. And now that I know this, anytime I need the base in a formula, I've got it. It's right here. There's the base. So the formula for squares is to integrate the base squared. Okay, so we are going to integrate 2 square root of 4 minus x squared, all that together, squared. And the only thing I need to find are my limits of integration. So if the base is top minus bottom, remember that I'm looking for the left and the right x values to make my limits of integration. So if you think about your circle, it goes from x being negative 2 to x being positive 2, and then we have our base and we're going to square it. So when you square this, negative 2 to 2, squaring this part right here is going to give me 4 times 4 minus x squared dx. And all I have to do to get this volume, remember it's a volume of a known cross-section, all I have to do is put it in the calculator with Math 9 like I showed you, and you're going to end up with a volume of 42.67, and actually we'll do 3 decimals, so let's do 42.667 units cubed. And sometimes they'll tell you what units to use and sometimes they won't. So in our case, we're just going to leave the decimal. So that's squares. Now, the hardest thing about this, and I haven't even tried to show you what it looks like because it is just that hard for me to demonstrate with my limited artistic ability what it would look like for squares to be coming off the page up at us off of the circle. So I'm not even going to try. What I am going to tell you to do is to do a Google search, look for volumes of known cross-sections, click on images, and you're going to see some different ways that this can look. Sometimes I think of it as bread because you know how bread's flat on the bottom and then it comes up in like little, I don't know what you want to call them, rectangles or squares or loafy shapes. That's kind of a fairly good explanation of what the cross-section would be like because the bottom's flat and then the picture comes up off of the page. But honestly, do a Google search and volumes of known cross-sections and you're going to see much better things than I could ever create. Okay, now we're going to do the exact same curve we had before. We're still talking about the circle x squared plus y squared equals 4. So our base we just found a moment ago was 2 times the square root of 4 minus x squared. So here's something to memorize. If you're going to have cross-sections that are equilateral triangles, your formula is the square root of 3 divided by 4 times the base squared. So here's our base, and it's going to be squared, and we're going to have the square root of 3 over 4, and I'm going to go ahead and integrate right between those since square root of 3 over 4 is a constant. My limits of integration are not going to change. It's still going to be from negative 2 to 2. So I'm going to have the square root of 3 over 4, integral of negative 2 to 2. When you square this, we're going to get 4 times 4 minus x squared. So now you can work it out by hand, or you can use Math 9, and you're going to get an answer of 18.475 for this volume. Now notice, when we had squares and when we had triangles, we had no need for a pi. There is no revolution. It's just a cross-section, so there's no pi involved. For our last example, though, we are going to be talking about semicircles. And a semicircle, the area of a semicircle is going to be 1/2 pi radius squared. Our radius is going to be the base divided by 2. So you see that there's a pi here, but that's because it's in the semicircle formula. It's only in this formula, it's not in the other two formulas. So if I have 1/2 pi, integrate the base divided by 2, remember my base is 2 square root 4 minus x squared divided by 2, and then that's going to be squared. So I'm still integrating from negative 2 to 2. So that's pi over 2, integration from negative 2 to 2. Notice that these 2's right here will cancel. So when I square this, it's just 4 minus x squared dx. So you can work this out, and you can leave the pi in it, or you can change it to a decimal. I changed it to a decimal. I used Math 9, and I got 16.755. Remember to round to 3 decimals. Okay, that's how you find the volume of known cross-sections.